This is a first introductory lecture into panel data. Handling panel data in econometrics is a huge topic, and the purpose of this lecture is just to introduce what we mean by panel data and the notation that we use dealing with panel data. So basically, a panel data is a cross-sectional sample of individuals. By individuals, we typically mean that in a generic sense, so it can be firms, countries, families, houses, and so on. So we have a bunch of these individuals, and we also observe these individuals over time. Here is a simple example of a panel. We have information from 140 firms, and they are observed from 1976 to 1984. So unit here refers to which firm we're dealing with. This data right here is data for the first firm. And the data in row 2 is for the first firm in 1976. NA just simply mean that we did not make any observations for this firm in 1976, probably because it did not exist in that year. Notice that we always tend to organize panel data just like this. So we have all data for the first cross-sectional observation first, then all data for the second cross-sectional observation. Then the data for each cross-sectional observation is sorted by time. This particular data is from a paper published by Arlano and Bond in 1991. The variables we observe is EMP for employment, IND is an industry index, wage, well that's the wage, cap, that's the amount of capital, and IND output is the production. For more information about this data set, you can check it out in Gretel, where it's called AB data. Just like when we're dealing with cross-sectional data or time series data, we identify a dependent variable, the variable that we want to explain using the other variables. Say, for example, that I want to use employment as my dependent variable. We use the index I for the particular unit, that is the particular firm. So I is any value between 1 all the way down to 140. So I goes from 1 to 140. For the time, it goes from 1976 to 1984 for each unit, even though the data is unobserved in certain years. So T goes from 1 to 9, where T equal 1 is 1976 and T equal 9, that's for 1984. So for example, if we consider this number here, that would be the employment of the second firm in 1978. And since we want to use employment as our dependent variable, we will denote this by Y. We will use two indices for the dependent variable, and the first index will always refer to the cross-sectional unit. So that would be Y2, comma, this is the third time period, 76, 77, 78. So 2 comma 3 is equal to 70.64. The generic notation for the dependent variable is y I comma t, where I is any number between 1 and 140 and t is any number between 1 and 9. Y I comma t is the observation of individual I at time t of the dependent variable. In this particular example, we want to use the employment as our y variable, and let's say that we want to use all these four variables as explanatory variable. The first explanatory variable, we call that x2, second one x3, x4, and x5. For example, this number here, 14.10, is an observation of the third explanatory variable for firm 2 at t equal to 3. So as you can see, we need 3 indices to refer to the explanatory variable. We always begin with the cross-sectional unit number, so that's this number here, 2. We continue with the index for time, and this observation is at t equal to 3. And finally, we put a 3 here to remind us that this is the explanatory variable denoted by x3. So the generic notation for explanatory variables are as follows: x, I, t, j, where I is the cross-sectional unit number, t is the time index, and j means that it's explanatory variable j. In this particular panel, we had 140 cross-sectional units and we had 9 time periods. The number of cross-sectional units will be denoted by n, and this number here, the number of time periods, will be denoted by capital T. So I is any number between 1 and n, t is any number between 1 and t, and if you look at the explanatory variables, j is any number between 2 and k. So a final point to note, it's very common when we deal with panel data to have these types of marks. That is, we have no information about the second firm in 1976. If you have observations for all cross-sectional units over all time periods, then we say that we're dealing with a balanced panel. If you are missing some data, then we say that the panel is unbalanced. Finally, let's see how we can pull panel data into Gretel and eViews. This particular data set already exists in Gretel, so you can get it by just doing File, Open Data, Sample Files. It's one of the Gretel sample files, and it's the first one, the AB data. So by just doing that, we get the panel data. If the data is in Excel form, you can import your panel data by just dragging the file onto Gretel. So start importing, OK. Found one sheet, 7 variables, 1260 observations. Close. It has just viewed this as cross-sectional data. Do you want to give it time series or panel? Yes, we want to make this into a panel. So we click panel. Stacked time series is the most common way of organizing panels. That's the way our is organized. We have 140 cross-sectional units, 9 time periods. And Gretel now interpret this as panel data. For example, if I click employment, we see that it goes from cross-sectional unit 1, time period 1 to cross-sectional unit 1, time period 9, 2.1 to 2.9, and so on. eViews is in general a little bit more clever at figuring out that you are importing panel data. Actually, I would be able to just click finish here and it would recognize this as panel data. But just to show you the steps that sometimes you have to do in case eViews doesn't recognize this as panel data. Step 2, just dealing with each variable. It's in step 3, that's the important one. We want to make sure that Excel understands that it's a dated panel. It has already figured out that the cross-section ID series is the unit and that the date series is the variable that we call year. And that will give us our data. We can be certain that eViews views this as a panel data because it says here 1976 to 1984 times 100 cross-sectional units, that is 1260 observations. So we are now ready to start analyzing this panel data.